In this video, I will be solving the following question.
Hello everyone, in this video I will solve more or less standard monopsony problem that one can encounter in intermediate microclasses. So in this problem we will have two sides. We will have two firms on the supply side. So we have competitive suppliers, and for them their production process is described with a cost function. For the first one, it's q squared over 4, and for the second one, it's q squared over 6, I believe. And so that's one side. And we can think about the suppliers as firms, let's say, producing some homogeneous good like electricity. And these firms will be selling their electricity to a monopsony that buys electricity from them and resells them on the retail market. So we'll have monopsony. And for monopsony, the one thing we will be given is the retail price of electricity. So retail price of 2, which means that the value function of the monopsony is given by 2 times Q. What it means is that effectively it's a revenue function, right? That if it buys Q units of electricity from somewhere, it will sell them on the retail market and will get 2 times Q. Let's immediately calculate marginal value, which is just 2. Okay, and for this problem, we will consider 3 scenarios. In the first one, the monopsony would not realize its impact on price and will act as a price taker. Therefore, it will operate like it in a perfectly competitive environment. Then the second scenario will be a real monopsony that doesn't allow to discriminate, but is allowed to pick any price in the input market where it buys electricity. And finally, I will show you what happens if the monopsony is allowed to do even more, engage in a first degree price discrimination. Okay, so let's do part A, perfect competition. So perfect competition we solve just to know competitive competition. We just to know what's this benchmark is, how much social welfare can be created in this market. Let's start work with our suppliers. We need a market supply curve, and for that we need to find their marginal costs. So marginal cost of the first producer is Q over 2. Marginal cost of the second producer is Q over 3. From this marginal cost, we can find the supply curves. These firms do not have any fixed cost. We can see that that all their cost depends on quantity. Therefore, they will supply at any price. So we just solve Q over 2P gives us S1 of P 2P. And analogously, Q over 3 equals P gives us S2 of P equals to 3P. Market demand is just the sum, so that's just 5P. And market inverse demand is just the inverse of this function, which is Q over 5. Okay, so we found that. Okay, so now let's solve perfect competition outcome, and let's do it with a picture. Standard picture we can draw in these cases. So we have price here, quantity here. Our competitive suppliers will supply at this level. So it starts at 0 and goes like this. So it's Q over 5. And our demand for electricity from the monopsony is given by its marginal value. Remember, the marginal value of monopsony at any quantity is just 2. So its demand is flat, like this, at 2. Now we need to find this intersection, and obviously this intersection is Q5 equals 2, Q star must be 10. So that's 10, that's 2. And so let's just write it down. So Q star is 10, the price in this market will be 2. Let's calculate individual supplies. So supplier 1 will supply prices 2, so he will supply 4 units. Second will supply 6 units, and their profits are so this one is sells 4 units at 2, and then its cost function is, so let's just write it down, 2 times 4 minus cost function is 4 squared divided by 4, so it's 8. 8 minus 4 is 4, and then P2 star is 6 times 4 minus 6 squared over 6, so 12 minus 6 is 6. Finally, so that will be our producer surplus here. So producer surplus, be careful here, producer surplus is for the suppliers. So just the sum of their profits is 10. And it actually can be, this is this area effectively. This is area of 10, you can see that. Notice that Monopsony, our retailer, let's call it PR, doesn't have any profit in this case because its demand is flat. So essentially it buys all this electricity at price of 2 and resells them to the retail consumers at 2 as well. So there is no profit. Social welfare in this market will be given by just consumer surplus, it's 10, and there is no DVL of any kind because it's perfectly competitive outcome. Now let's solve part B. Let's solve. Okay, so that's Monopsony linear price. So in this scenario, Monopsony does realize that it can its impact on price. So if it if it decides to buy less from the suppliers, the price will drop, and Monopsony will be able to make some money. So let's start with Monopsony problems, and its buying cost is given by the quantity it buys times the inverse supply curve to this market. So its buying cost is actually Q times Q over 5. That's the number we derived, it's Q over 5 from here. So it's Q squared over 5, and its marginal buying cost is 2Q over 5. Okay. Now, as a result, we have what? So Monopsony will pick its quantity, Q monopolists, such that its marginal buying cost, 2Q over 5, equals to its marginal value, equals to 2. Therefore, we see that, let's solve. So QM in this sense will, in this case, will be 5, and the resulting market price will be 2.5. PM. No, sorry. The price will be, just plug it in here. Don't plug it here, plug it into the real inverse. So 5 is just 1. Okay, so how we can see it graphically? Well, so instead of having this marginal value of 2, Monopsony will be buying at a point where this curve intersect, where its marginal buying cost intersect with 2, so it goes like this. That's MBC, which is twice as steep, and we'll pick the price and quantity here. So we can, and the price will be 1 here. Okay, so in this case, let's calculate the profits. So for the first supplier, its profit will be, well, first of all, let's start like this. Q1 star will be given by, at price of 1, the first supplier will supply 2p, so he supplies 2. Second supplier supplies 3. The profits will be given by, so they sell their product at a price of 1 times 2 minus 2 squared over 2. Oh, sorry, it was over 4. Right, yes, okay. So profit is 1. And P2 star is then, it sells, price is 1, it sells 3 units, and its costs are 3 squared over 6, I believe. Let me check this, yes. So 3 minus 9 over 6, so it's 3 minus 3 twos, so 1.5. But now we'll have Monopsony profit that it created. So Monopsony profit will be, it buys, notice basically the difference now. It buys at 1 and sells at 2. So it will sell 5 units at 2, and then it bought them at 1. Therefore its Monopsony profit is 5. Total social welfare is sum of all these numbers. Sorry, let's be careful. So producer surplus is our producers, 2.5. Monopsony profit, we can call it consumer surplus in this case because Monopsony is a consumer, has 5. Here it was 0 for Monopsony. Total social welfare is 7.5, and therefore we can see that the dead weight loss created is 2.5 here. Essentially, this area here is dead weight loss. That's is due to Monopsony market power. Okay. So relative to perfect competition outcome, we can see that production dropped. The price of the electricity on the market dropped to 1. So Monopsony buys at 1 and resells it at 2, and social welfare is reduced. So finally, let's solve for the Monopsony outcome under first degree price discrimination. So usually solving for first price discrimination is easy. All you need to do is use the numbers that you found for perfect competition, if you found them, to create the outcome. So under first degree, so part C, first degree price discrimination, effectively our Monopsony will offer to buy electricity from the suppliers using a two-part tariff. So it will offer a two-part tariff to firm 1. It will say, okay, in order to buy from me, you need to pay me an entrance fee, kind of a sign-up fee to work with me, and then if you pay that fee, you will be able to buy any quantity at the price I specify. So effectively, it will be a fixed fee plus some linear price times quantity, and it will offer a similar contract to firm 2, but naturally our Monopsony can differentiate between the two firms because of first degree price discrimination. You're allowed to discriminate based on the identity of your of the other party. So entrance fees can be different, and this prices that you pay per unit can also be different. And for first degree price discrimination, we know what will happen, that First of all, our monopsony, will set the price, the linear price equals to 2, to the perfectly competitive outcome. And then it will charge our, as an entrance fee, it will take all the money that the company make. So fixed fee for firm 1 will be 4, fixed fee for firm 2 will be 6. So under the structure, the firms will deal with the monopsony. They will pay fixed fee, they will enter and they will buy the quantities that we have here. So Q star will be 10, Q1 star, first firm will buy 4, and second firm will buy 6. Notice, however, that now their profits will be 0, because all the profits they were making from buying this quantity now are reduced by the amount of the fixed fee. So it's 0 here and 0 here. Our producer surplus now is 0. Our consumer surplus is consumer surplus that Monopsony was doing before, which is 0 because it was not making any money, plus the entrance fee it collects from these two firms. Therefore, it's 10. So all this social welfare has been translated to the monopsony. So social welfare is 10, and as usual, there is no deadweight loss in this case, and the intuition is very simple. Once we allow monopsony to price discriminate, it can capture all economic pie, all economic surplus. Therefore, there is no reason to distort it. What monopsony will be doing, it will maximize it as if it was a perfectly competitive, socially optimal outcome, but then take everything as a profit. Thank you.